Okay, let's get started here. Sally, why don't you grab one off my desk there, the right top. Anybody else need a calculator today? Can you grab one for John Griffin?
Elijah has two calculators. Which one's faster?
Okay, we're going to start with the bell work problem, which is number 174. So in your bell work book today, whoops, number 174 on chapter 10. So always start by writing down what we know, what we don't know, what we're looking for. In this case, we're working on the Statue of Liberty. Ooh, that's cool. Anybody ever been to the Statue of Liberty? Yes? Yeah? You ever climbed to the top of it? I haven't, but I did see some really cool superhero movies where they had a final battle on the Statue of Liberty. It was an X-Men, I think. And, okay, so the copper that was originally built, the Statue of Liberty, the outside was coated with copper when France delivered it to us 100 years ago or whatever it was. And so copper changes color as it's exposed to the atmosphere. A lot of times it's simple things like copper chloride or copper hydroxide or copper oxides. In this case, it's something crazy. And so they call it a patina, P-A-T-I-N-A. And some people like that color. I've watched some of these do-it-yourself shows on TV, and they say, hey, we want copper, but we don't want the bright, shiny copper color. We want something that's started to patina. And it's where it starts to age and shows us different colors. So that's what we're trying to calculate here in number 174. What is the percent of copper in these two different kinds of basically copper sulfates or copper hydroxide sulfates? I don't even know how to name these guys, but the first one is Cu3 parentheses OH parentheses, and the first one has 4 hydroxides and then a sulfate. And the second one, we're going to do both at the same time because we do exactly the same thing for both of them. The second one is Cu4, I think 6 hydroxides. Somebody correct me if I'm not correct, and then a sulfate. Okay? So 2 different forms of copper patina. Let's just call it that. And we need to know what the percentage of copper is in this whole thing. So this is kind of like the problems a week ago, like last Wednesday when we did percent composition. But I don't need to do every element here, I just need to know copper. So what we need to do is add up the molar mass for this whole thing, and then take the copper and divide by the total. And we're done. And we're going to do the same thing over here. What's the formula mass, or the molecular mass, or the molar mass for this whole thing? And then we're going to take 4 coppers and divide by that total, and we get the percent. So let's figure it out. I've got 3 coppers. How many oxygens here? Riley? How many oxygens buried in this thing here?
8.
Yes, 4 here and 4 here. How many hydrogens? Riley?
4.
Good. And we'll just 1 little old sulfur. On this side, we're going to do the same thing, but the numbers are going to be different. So I have 4 coppers. Here we've got 10 oxygens. That's not 100. Everybody knows when I write oxygen, that's not 100, that's 10 O's, okay? And then 6 hydrogens and 1 sulfur. So I need the molar mass for copper. Who's found that number? John Griffin?
63.546.
Okay, 63.546. And oxygen we know, everybody almost should have it memorized, 15 point. Okay. Hydrogen, 100. I call this, this is James Bond's evil twin brother, 008. Not 007. 007 goes with nitrogen, by the way, it's 14.007. That's the James Bond one. Sulfur, 32 point something.
32.066.
065, 066. It's different by 1,000 in your book that up there. Don't sweat it. Okay, 32.065 according to my wall, 066 in the book. but don't, somebody brought that up last period, I just blew them off and said, don't worry about it. Okay. So we're gonna multiply them, add them up, and then we got one more step to do in a second. Okay, I can't do these ones in my head. 63.456546 times 3. Sheila, you got this one? Copper times 3.
190.638.
Okay, and oxygen times 8. Sam?
127.992.
Okay, and we add them all up. And who's got the total for this one right here? Eli?
354.727.
727. Boeing. Stratoliner. Been on lots of those airplanes in my life. Okay, we'll finish it in a minute. Let's do the same thing over here. So 10 times this one is easy, 159.99. I can multiply anything by 10 by moving the decimal. Okay, and then 4 times this one, 120, 130, 260. Okay, one person. Sally.
254.
Yeah.
.184.
Okay, and what do you got for total, Sally?
452.287.
Okay. Now, when we did these types of problems way back a week ago, we had to calculate it for every element, but this question is only asking us for copper. So I'm going to take this number, divide by this number, and get that answer. And I'm going to take this number, divide by this number, and get that answer. And we're done. Multiply by 100 to get the percent. Okay, so this one, Sally?
53.7.
53.7%. And on this side, .2. Let me check those answers, but they sound right. .7, 56.2. Perfect. Okay. So this is a percent by mass. And when they could ask you to do it for all the elements, in this case, just one of them. We can do it for H2O. Remember the very first day? We did it for H2O. We had 11% hydrogen and 89% oxygen. Yeah, we did 2 hydrogens and 1 oxygen. Real simple. Okay. In your Bell workbook, questions? This is basically the opposite of what we're doing now. The empirical formula, you can see we're working from this back to this and then figuring out the formula. So this is the opposite. Percent by mass is the opposite of figuring out an empirical formula. Okay? In one case, we're taking this, calculating masses, and then percent. Empirical formulas, we'll start with percents, calculate masses, go to moles, and then we figure out the formula. Okay, let's do a couple problems here. I'm going to let's do the caffeine one, okay? I didn't do this one last period. So number 168, last night's homework. Now again, if you didn't do last night's homework, then please try and do it yourself tonight, okay? If you did do last night's homework, then follow along, see how you did. Okay. Everybody loves caffeine. The stimulant effect of coffee and tea, by the way, and in chocolate, and in cocoa, and hot chocolate. I love that hot chocolate song from Polar Express, right? Hot chocolate. And so that's caffeine. Someday they'll come up and tell us it's bad for us, but until they do, we can partake, right? C8H10N4O2. Oh, this is just a percent composition problem. We can do it, but it's very similar to the Bell work problem we just did. Let's save it for tomorrow. I want to do a molar mass and empirical and molecular formula ones. So, good one that I didn't do last period. Did we do the monosodium glutamate problem yesterday, MSG, which is number 172? Anybody? Yes, I think so. Let's do 173. What is the empirical formula of a compound that contains the following? Okay, I got nitrogen and or nickel, carbon, and these three things. Nick and night. Anybody remember Nick at Night?
I did.
George Lopez.
I don't think I ever watched it. 10.52 grams. Carbon is 4.38 and 5.10. 4.38, 5.10. Okay, I'm going to put some columns here. I just like working in columns. It keeps me organized. Now, think about this for a second. This one already gave me grams, not percent. What would be my first step here? Raise your hand. What would be the first step? Every other problem we've done, we're asked for an empirical formula. We always start with percents. But this one doesn't. Read.
We have the total of them all.
I could. Okay? So I can add them all up and divide each of these by the total and get a percent. Now, if I do that, please don't do that. If I do that, what's going to be the second step? Change them all back into grams. Okay? So guess what? When we start with percents, the first step is to change them into grams. If they give me grams, I'm a step ahead. They've already done it for me. Okay? I don't need to figure out percents. Okay? So we're good just to start and plow into moles. So let's find a molar mass for carbon, nitrogen, and nickel. 1 mole. We're going to multiply by each of these to change these into moles. Nickel. Who's got my periodic table? Laney's staring up there already. Huh?
20.
Group 10 under the transition metals. Should be right next to copper, zinc.
Oh, okay. 58.693.
8.693 grams. Carbon, of course, we've almost got that one memorized. I know I do, because we've used it almost every problem this week. And nitrogen is, which is what I mentioned, 14.007. That's the top secret service number, okay? So we're going to take 10.52 divided by 58.693, 4.38 divided by 12.011, 5.10 divided by 14.077, and see what we get. And you're going to help me so I don't have to punch my calculator. We've got the first one. 10.52 divided by 58.693. Right? You got it? Nope. Lane?
0.1792.
1792, okay. And that's moles. That's better. I need him. 4.38 divided by 12.00011. Kill?
3647.
And 5.1 divided by 14.007, Elijah.
0.364.
It looks suspiciously like the one above it, doesn't it? Okay? So, what was our next step? We need to change all these into a ratio of moles. How do we do that? Read.
But divide them all by the smallest mole.
Okay. So there's two numbers here that are essentially the same, 0.364. So let's divide all three of these numbers by 0.364, 0.364, 0.364. That one's going to be 1, that one's going to be 1, and this one looks, I don't know. Somebody tell me what you got. 2 point what? No, I don't think so. Set 0.17. What did you say?
Wait, 0.17 is less.
Yeah, it is less. It'll be less than 1. 0.1792 divided by 0.364. Oh, is that the smallest one?
That's the smallest one.
Duh. Okay. Okay, so let's divide them all by 0.1792 then, okay? So let's erase this, erase this. Don't make me do all this work without correcting me. Help me. 0.1792. Oh, I think it's Reed's fault. You told me divide by 0.30 and 3.36.
I saw the 7 by north of 1.
Okay.
Blame it on Reed.
Yeah, I did the same thing because I was thinking like you.
Well, would we be wrong if we went ahead and rounded that one off? Like the 0.1792, like if we rounded off to 0.18?
Let's find out. Okay, so what do we get here? This one's going to be 1. This one's going to be
2.035.
pretty close to 2, or 2.03 and 2.03. So that's really close to 122, okay? Again, it's within a tenth either way, pretty much rounded off. So what's our formula going to be? Ni, 1, C, 2, and 2. Now this would be correct. I would mark this correct, but what do you think the real formula is? Anybody want to take a stab what this might be? It'd be the same elements, same ratios, but there's a better way of writing this. Anybody see something here? Hunter?
Is it the cyanide?
Yeah, it's probably cyanide, so it's probably nickel 2 cyanide, Cn parentheses 2. I'm guessing, because nickel is +1 and +2, cyanide is Cn, one of each. We can stick it in parentheses and it balances out. So I would not mark this wrong for you guys this week, okay? But both of these are fine. It's the same ratio. 2 carbons, 2 nitrogens, 1 nickel. Good? Let's see what the book says. Yeah, they write it like this, nickel cyanide. Okay, let's do another one here. I want you to jump with me to the end of the book, page 982. There are some supplemental problems. Sarah?
So what did we just find?
Empirical formula. Okay? The empirical formula is the simplest whole number ratio of atoms in a molecule or a formula unit. Okay? Empirical. E-empire. It looks like empire. E-M-P-I-R-I-C-A-L. Okay, let's do a couple molecular formula ones, because some of you have been absent and you didn't see that yesterday or the day before. On page 982, I'm going to do a couple problems here. I'm going to do one more with you, and then I'm going to let you work one and see how you do with it, okay? Actually, let's do number 32 first. Okay, analysis of a 15-gram sample of a compound used to leach gold from low-grade ores is as follows. 7.03 grams sodium. This is just like the one we just did, so I'm going to let you work on this in a minute. So go ahead and write it down and get started. 3.68 grams carbon. And 4.29 grams nitrogen. 29 or 92? 4.29 grams of nitrogen. Okay? Exactly the same. It even starts with grams just like we did here. Okay? So take a minute. If you got the answer, point to it when you get there. Okay? I'll give you about 4 minutes. You're going to work up that list. Maybe about 4. This is already grams. We need to change it to moles. We need to get a ratio. Next page, 982.
Next.
Number 32.
32.
Okay, 32, 984. Next page.
Oh, 984.
Oh, wait.
982.
Yeah, page 982, I'm sorry. Yeah, page 982. Number 32 on page 982. But that's why you get started. We're not using any exponential notation or Avogadro's number, so it'll work. I call that my gumball machine calculator. But it works. It's great. Use the periodic table on the wall, the periodic table back of your book. Paper? You need some? Your notebook? I'm a fan of using a notebook to put these problems in, because when it's time to study for the test Thursday night, you'll have all of these problems in a single place, cool, okay? And you won't have to go, what page did I write that on? It's just not organized. Organize or agonize? Is that what it looks like to me? I don't even know, I haven't done this one yet. Yeah, good job, Ashanti. Hey, right on. Right on. Right on. What you got? Something went wrong. Yep. 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 Oh, you got it right there. It's very similar to the last one we just did. Okay? Everybody should see the similarity. Once you see that nitrogen and carbon. Yep. 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 I like this. Didn't see those. Oh, yeah, I didn't see the formula. Yep. Don't need the parentheses if there's only one of them. Okay, so we're going to change each of these into moles. So sodium, 22.9, right? Grams per mole. Carbon, 12.011 grams per mole. Nitrogen, 14.007 grams per mole. Divide, and I saw a lot of you have the same three numbers. So 0.33 roughly, or what was that?
306.
3056,
306. Point 306.
Kristen,
06.
306, okay, I'll take that. Okay, close enough. 306, 306, 306. I know they might be off by 1,000th or something like that, one way or the other. Essentially, all three numbers are the same. There we go. Essentially, all three numbers are the same, okay? And so when we divide by the smallest number, we're going to get 1, 1, and 1. 0.306, 0.306, 0.306. So our empirical formula is NaCN, sodium cyanide. Okay? These problems right here, this is the meat and potatoes of this chapter. If you can do this, and I saw more than half of you, probably 2/3 of you got it for sure, and the rest didn't finish when I walked by. You're showing me a whole bunch, 5 things we've learned. Okay, number 1, you know how to look up a molar mass on the periodic table. Number 2, you know how to change grams into moles using a molar mass. Number 3, you know, if I do a molecular one, which we're about to do, you know how to calculate a molar mass for a compound. We didn't need to do that here. Number 4, you know what a mole is, and so on and so on. So there's a whole bunch of stuff buried in here. You're doing great. Let's do one that has a molecular formula. Right above 32, nope, let's keep going. Right above that is number 30. I like the eucalyptus problem, okay? Who eats eucalyptus? Why?
Koalas.
Koalas do. And this problem, though, it tells us panda bears, okay? So panda bears, koala bears, okay?
What?
Same thing.
What?
Fantasy bamboo.
They
Anyway.
do, but they also like eucalyptus evidently, Elijah, okay? Eucalyptus leaves are a food source for different types of bears, pandas, or koalas. Eucalyptol is an oil found in these leaves. Analysis of this indicates it has a molar mass of 154 grams per mole. Save that number, we're going to use it at the end. So I like stick it up here yesterday, because I'm not going to use it right now. Just save it for the end of the problem. That is the molar mass of this molecule. So then it gives me the percent composition. Carbon, hydrogen, oxygen, 7787, 1176, 7787. 776, and oxygen 10.37. Now these are percentages. So first step, we need to change them into grams. If I assume a 100-gram sample, they don't change. So if you want to make another column, we can change them into grams like this. And then we're going to change them into moles. Okay? And again, you'll see carbon, hydrogen, oxygen, carbon, hydrogen, oxygen, carbon, hydrogen, oxygen, over and over again. Okay? 12.001, 1 mole. Hydrogen, 1.008. Oxygen, 15.999. You crunch some numbers here. 7787 divided by 12.011.
Always the same as the grade?
Yes. Now sometimes they will start with grams, like the last problem, the last two problems we had. Okay.
And it'll just switch over. You don't have to change decimals or anything?
Right. Here we just assume, since that's telling me how much stuff I have, we assume a 100-gram sample. You weren't here for that one. So if I assume 100 grams, nothing changes. For any 100-gram sample of eucalyptol, it's going to have 77.87 grams of carbon, 11.76 grams of hydrogen, and 10.37 grams of oxygen. So yes, it's very safe. The method is proven. It's not an if, it's always. Divide by the smallest one, see what you get. Okay, once you get those moles, then divide by the smallest one to figure out what your ratio is going to be. Yes. Weird, huh? Weird looking. But that's it. That's it. Yes. That's it. That's it. I'm so excited. I love when you guys know what you're doing. It's like, oh, yeah. Look at this. Yes, I get it. Yeah. He's still punching. Good. Round that off. Of course. Right. Yes. Write the formula. Okay, so divide each of these numbers by that to get one more column of numbers. Yep. Yes. Okay, let's look at this together to see what we got. Yay, okay. So, 77.87 divided by 12.001. Angela.
6.48.
Great
Ask
job.
me, tell me.
That's great. Great.
6.4.
6.48, yes. Okay. 11.76 divided by 1.88, Savvy.
Is it 11.67?
I don't know.
That should be
Tell me
it.
what it is.
Yeah,
Yes.
11.6.
10.37 divided by 15.99, Sophie.
0.648.
0.648. Now, this is a good sign. If you see 0.648 and 6.48, oh, this looks good. Let's try it. So we're going to divide all three of these by the small number. 648, 648, 0.648, and you get 7,
10.
and
18.
and.
1.
Is that cool? It looks weird, but that's the answer. Now, it's not the final answer. The answer here, our empirical formula is C10, H18, O. And you go, O? Like, O, just like one lonely little O. Okay? Now, we're not done the problem. Okay, we'll go back and reread the problem. The problem says, find the molecular formula if, and then it gives me this number up here that I stuck in the corner. Okay? Now, the molecular formula, for the sake of those who are absent, and the empirical formula are like, and I've still got it on board over there. If I had sugar, we talked about this the other day, sugar is C6H12O6. It is. The sugar that you and I eat, the sugar that's in our carbohydrates, the sugar that's in our candy, sucrose is this. But this is not an empirical formula. The empirical formula for sugar would be, we can reduce this, right? 6, 12, 6. So the empirical formula for sugar is CH2O. Okay, so the difference between a molecular formula and an empirical formula is just a factor for all elements. Same factor. Times 6 times 6 times 6. Okay? We did one yesterday in class, and so those of you who weren't here yesterday, we did one of the homework problems which said the empirical formula was NO. Remember the just say no problem? And the molecular form was N2O2, dinitrogen dioxide versus nitrogen monoxide. Two different things, completely different compounds, different properties, but they have the same empirical formula, the same ratio of atoms. This, by the way, goes back to what we talked about way back, I think it was in chapter 4, where we talked about the law of multiple proportions. Does anybody sound familiar? Okay, it was when we talked about the history of the atoms. We had the law of definite proportions and the law of multiple proportions. This is the law of multiple proportions at work. It says we have empirical formulas, but we can get a whole bunch of different things with the same ratio that have different properties. And there are others that have this same ratio, by the way. And others, I think, don't know about that one. Good? Okay, so let's go back and finish this up. So this one says the molecule has a mass of 154 grams per mole. So we need to figure out what the mass of this is. So we're going to calculate the molar mass for this guy. And it's 10 times 12.011, 18 times 1.008, and 1 times 15.999. That have it. 1 times 15.999. Okay, so we calculate that, and we're going to divide this number by that number to figure out what our multiplier is, to change to our molecular formula. That's 120, by the way, and that's 18, and that's 16. I rounded off. Read?
But didn't you say you can't trunk numbers?
Can't what?
You can't trunk numbers?
Truncate them? No, I don't. I just round them off for the sake of speed. If you're doing it for a test, then you don't want to round off. Okay? 154, 154. In this case, guess what? Same thing. Okay, so the molecule and the empirical formula are the same. So we'd say the molecular formula is also C10, H18, O. But how about if they had told me this number was 308? Okay, then I'd take this divided by that, and I'd get a 2, and I'd have, my answer would be C20H36O2, if there is such a thing. Okay? So the molecular formula is always a whole number multiple of the empirical formula. Let's do another one. Okay? Everybody's doing great. On the same page.
Can you do number 66 in the chapter?
Let's look at it. Is there something about it?
I can
Rocket fuel. 66. Did I get this?
Yes, she did.
Hydrogen, cool. Hydrogen peroxide, cool. Process reaction. Needed to produce. Oh, I'm in chapter 11. I'm glad I'm not doing number 66 in chapter 11. Good, you don't want to do that one yet. I'm going, boy, I don't think we've covered this yet. That's pretty funny. Okay, 66, pain reliever. So you want to do morphine. Okay, let's do morphine. Gotta love morphine. We've done caffeine, might as well do morphine. There's a problem in here about aspirin too. Everybody see the formula for aspirin? Okay, this is a pretty simple one. Okay, tell me, Sally, what do we got for composition?
Carbon is 17.900.
Okay,
Hydrogen is 1.680. Oxygen is 4.225. Nitrogen is 1.228
grams or percent?
grams.
Okay, so grams, 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 grams. We don't need to worry about changing them into grams. They're already in grams. And we're asked, number 66, determine the empirical formula.
See,
Okay? Same steps. That says mole. You guys, I always start writing really fast on 6th period. I'm sorry. But by the end of the day, man, it's like I've written this so many times. MOL, 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 MOL. Okay? Yesterday was molecule, 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 molecule. I'm just going to cut and paste on this. It'll be kind of fun. Okay, so what do we got? Tell me some numbers here. It needs 17.9 divided by 12,011. Savannah.
1.5.
Good. 16.8 divided by 1.008. Savannah?
1.67.
Okay. I like this. 4.225 divided by 15.99.
0.26.
And 1.228 divided by 4.14.
0.09.
Okay, which one are we dividing by?
0.09.
Okay, pick the small guy. 0.9. 0.9. 0.9. 0.9. Okay, Savannah, what you got?
You want me to give them to you rounded or not?
Not.
Okay. 16.56. 18.56. 2.89.
1. They rounded him off. I don't like that, but so they went C17, H19, O3, and 1. I hesitate to round these off, because in normal circumstances, I try and multiply these by 2 to get rid of something that's close to a half. Okay, and I'm gonna do a problem here in a minute where we have one that comes out to be a half. Usually if you have something over here that's 0.5 or close to it, we're gonna double all the numbers to get rid of that half. In this case, it's such a weird one, morphine, that they actually went 17, 19, 3, and 1. Again, you need to be really careful with these. I wouldn't give you one that was that far off that you had to make a decision whether to round it off or to double all the numbers, okay? So the answer is, according to the book anyways, CH O3N. And it's probably nitrate at the end, NO3, I'm guessing. But what did they write here? That's the way they wrote it in the book, but I'm guessing this is NO3, nitrate, attached to a big long chain of carbons. Now, you probably got there. You just question it, what to do with these.
Yeah, that was confusing.
Yeah, okay. I'm going to show you another one where we don't want to do that. Let's go back to page 392. Got time for one more. Not 392, 982. Yeah. Which one was this? Hang on a second. Let me scroll back here. Where are you? 26, 76. 29. On page 982, okay? I'm going to go fast. Copy it down. Carbon, hydrogen, oxygen, 2676 grams carbon, and I'm changing them right away to grams instead of percentages. 2.21 on the hydrogen. So I'm skipping a step, but I know that I'm always going to change them into grams if I'm given percentages. And then 71.17 grams of oxygen. Switch back to black here. So 12.011, 1.008, and 15.999 grams, grams, grams. Gotta love CHO, right? There is literally millions of things that have CHO in it. Like I said, most of your body, and there's a billion different things in your body, not billion, there's millions of different compounds in your body. They're made up almost exclusively of this carbon, hydrogen, and oxygen, occasionally nitrogen, and a little bit of phosphorus. Okay, so we get three numbers here. Anybody want to do this for me? 2676 divided by 12. 2.2. And 2.21 divided by 1.008. 2.2. 7117 divided by 15999.
4.5 maybe? 4.45.
4.45.
Really?
4.45.
Oh, okay. Divide by 2.2? Yeah, this works. So divide by the smallest one and we get 1, 1, and 2. That's not the one I was looking for. Anyways, CHO2.
Yep.
That's the one I was looking for. Well, we're done. We're out of time. We'll do more tomorrow. Okay? Feeling confident, hopefully a little more confident than you were yesterday. Finishing touches on last night's homework. Bring it tomorrow. Bring your questions, anything from chapter 10. Listen, real quick. Section 5 is a 5-minute deal. Okay, I'm going to spend 5 minutes on section 5 tomorrow if you want to read it about hydrates. We mentioned that the other day. It's how to name hydrates, and that's pretty much all I'm going to cover in that section. Okay, so don't sweat it. We'll spend most of tomorrow doing more review, and then we'll cover hydrates right at the beginning so you can know what they are. Okay? There she is, Riley Thomas. Riley Thomas. Riley.
Alright, Ms. Deskey?